What's up, kids? Mr. Murray here, Mr. Murray's Mathland, and today we're taking a look at geometric sequences. This is a kind of an intro, basic video, but geometric sequence is essentially an exponential relationship where each term is multiplied by a common ratio to get the next term. So keeping that in mind, here's sort of the format as it's usually presented. Is that a sub n, the explicit definition for the nth term, will always be the first term multiplied by r, that common ratio, raised to the n minus 1. And the first term is, pretty obvious. That's what's first if they give you the list of terms. In this case, it would be 5. The r value is that common ratio, or in other words, what are you multiplying by each time? And sometimes that's really easy to see. What are we multiplying 5 by to get negative 15? You're multiplying by negative 3. To get from negative 15 to negative 45, you're multiplying by negative 3, etc. If it's not so obvious or apparent, you can always find r by doing a ratio of any term to the previous term. You can take a2 and divide by a1, or a3 and divide by a2, or etc., etc. In this case, the negative 15 divided by 5 gives you that negative 3 you're looking for. Or 45 divided by negative 15 will give you that same negative 3. In fact, maybe that's a way to check that you have the correct r value, or that it is in fact geometric, if they haven't told you, is to do the ratio of a couple consecutive terms and see if you get the same ratio. So anyway, we know what a sub 1 is. It's 5. We know what r is. It's negative 3. So this is really just a matter of substituting into the format here. That the first term is 5 times negative 3. Now, if the r value is negative, you probably want to use parentheses around it, to the n minus 1. And that would be usually what we're looking for here, or as most textbooks would have it. But, suppose, you don't like to have the exponent be n minus 1, or if that's not, it's a multiple choice kind of situation and that answer isn't, present. There's another way of doing it, which is instead of, using a1 and n minus 1 as your exponent, using the 0th term, so using the previous term. Now, what term would have to come, before here is if you divide by that, r value of negative 3 to go backwards 1 and kind of find the preceding term, and that would be negative 5/3. So some people would write this, and not that that's better or worse, but they are equivalent. Like a good way to check is, notice if you plug in if you plug in 1 into either one, if you plug in 1 to here, 1 minus 1 is 0, and negative 3 to the 0 gives you 1, so you get 5. If I plug 1 in for n here, you're getting negative 3 to the first, which is negative 3, and negative 3 times negative 5/3 will still give you positive 5. So regardless of what format you use, if you plug in 1, you should get out 5. If you plug in 2, you should get out negative 15, etc., etc. Okay, so just one more example here. Write the explicit definition for this sequence shown. And again, you want your first term, that would be 54. Your r value, that common ratio, what are you multiplying by? And if, again, maybe this is not that obvious to you, maybe it is if you're really good with numbers, but that would be take any term and divide by the previous term, if it in fact is geometric. If you take 36 and you divide by 54, that is a ratio of, they're both divisible by 18, that reduces to 2/3. Or if you see the terms are getting smaller, sometimes it's easier to grab a later one. If you're working without a calculator, and say 16 divided by 24, both divisible by 8, still gives you 2/3, so that's your r value. And so here we go. A sub n will be that first term, 54, times your r value of 2/3. raised to the n minus 1. There you go. If you did want to use that uh, other format, the ratio is still the same of 2/3, but this one would be if your exponent was n, then you would use the 0th term, and what kind of comes before 15. So if your r value is 2/3, that's what you're multiplying by each time, then you have to divide 54 by 2/3 to find out the preceding term. Or take 54 and multiply by 3/2, right? A little keep change flip. 2 goes into there, 27. 27 times 3 is 81. That would be sort of your 0th term here. And so you could take 81 times 2/3 to the nth. So again, notice a good check here. If you plug in 1, you should get 54. If I plug in 1 into this, 1 minus 1 is 0, and 2/3 of the 0 is just 1. So we get 54. If you plug in 1 into this format, now you're actually doing 2/3 of the first, which is 2/3, and then you're doing 2/3 of 81. And 2/3 of 81 is 54. 3 goes into there, 27. 27 times 2 is 54. So two equivalent equations, both good, whatever works for you. If you got any questions, let me know. And if you want to see a more complicated problem, check out the video too.